Hello everyone, welcome to my routing and switching video series. So this is part number two. In part number one, you have seen how I went over with my network topology, showing you the campus one and campus two, and we have some users sitting in there. They are all connected to this core switch. Our core switch is connecting to the router one um, on a OSPF. And router 1 is connecting to ISP1 and ISP2 for our WAN links connecting towards data center 1 on the top and sitting in New York, and data center 2 based at Dallas. And as you see here, in the previous video, what we did, we only had layer 3 connectivity. So we configured the OSPF, and the user sitting in campus 1 and campus 2 were able to reach till router 1. Router 1 does not have any connectivity to ISP1, ISP2, neither it has any connectivity to data center 1 or data center 2 based at New York and Dallas respectively. And in our data centers, I have also mentioned that we have our core switches here, switch 2 and switch 3 are connecting to the router 1, router 3 and router 2, and they have OSPF running in. Usually in live environment, we don't configure OSPF. We have IBGP as IGP, internal BGP. But for the sake of this video, I configured OSPF. But in future, as we keep progressing with various scenarios, various routing situation, various routing discussion, and as we get more deep dive, I might change the setup. We will we'll clear this OSPF and configure something else. So you will be seeing a lot of changes on this diagram. We would be adding more stuff, removing some stuff and all. So just make a note of that. And so let's start with our agenda of this video number 2 is to configure the BGP between router 1 and router 2, router 1 and router 3, and see what routes router 1 would be learning from data center 1, data center 2, and what routes data center 1 and 2 would be learning from router 1. Our expectation is the campus 1 and campus 2 user should be able to reach towards the New York, the destination, their end destination in New York and Dallas, and should be able to access anything hosted or any network sitting behind 133, 143, 153 network, or in case of New York, 188, 178, and 168. Any network, any VMs or any storage database servers or anything there, they should be in a position to access them, and we should be have full point-to-point connectivity. So if I log on to my external switch 1, where my campus 1 and campus 2 users are sitting, if I do show IP, let's see what scenario, what we have here in my routing table. So we only have 100.0.0 route, 200 and 192. 100 is this, 200 is this network, opposite campus network, and 192 is the route going to the router 1. And as we speak, we don't have any network from our we're not learning anything from our resources, our stuff we hosted in data center 1 and 2. If I jump onto the router 1, let me see what routes I have here. Show IP route. Alright, so on router 1 we have 100.100 campus network, 170 to 168 is pointing to ISP1, and 10.0 this network is pointing to ISP2, and 192.168.1.0 is pointing to the core switch. So router 1 has no idea about this 178, 168, and 188 networks. So let's go ahead and configure the BGP between router 1 and router between router 1 and router 2, and router 1 and router 3, the ISP2. So let's just the best idea is to see if I have any BGP configuration on my router config. So BGP, let's see what configuration we have. We don't have anything, and so the first step would be I would ping my peer IP address, 172.168.1.2. Alright, I'm able to ping him, and let's ping the ISP2 router 10.1.1.2. Okay, for some reason we don't, it's pinging. All right, because before you do any routing configuration or anything, the basic thing is to see the port is up, the WAN link is up, layer 2 is up, layer 3 is up, and we have um, at least ping going between both source and destination. Once ping is going, then you can troubleshoot the routing. If the foundation itself is not working, then it doesn't make any sense to spend hours and hours troubleshooting the routing when the port itself is down or we don't have layer 3 connectivity. So let's go into the config mode, conft. Let's call router BGP. The IS number is 100. Neighbor 172.168.1.2. Remote AS. The ISP remote AS is there are so let me make some correction here. I'm not bringing the BGP on ISP1. Basically, I'm bypassing the ISP1. For now, in this video, ISP1 is only a medium connecting between router 1 router 2. So I would be configuring the BGP in my router 2 based at data center 1 in New York. So, I mean, in some scenarios, what you'd be doing is you'd configure a BGP between router 1 and ISP router. Then the ISP guy, the engineer sitting in working for that ISP network team, would configure a BGP from the other end of their network towards this router too. So for sake of this video, I'm not going to do that. So to keep things simple, we will have a direct, just imagine it's a point-to-point direct connectivity link, but yes, ISP is the one who would be providing you those services, right? So remote AS here is 200. So I'm basically configuring BGP between my router 1, which is sitting in my campus network, towards the router 2, which is the edge router, the entrance point in our data center 1 in New York. Remote AS 200, right? Let's make a habit of putting descriptions here. NY underscore BC, right? Let's configure the BGP for other neighbor also. 300. This is for the Dallas data center. 10.1.1.2. Description: Dallas underscore DC. And so let's go and look my configuration one more time. It's very simple. I want to add a few more lines here. Okay, so this soft reconfiguration inbound command I am using. So once our routing is up, we are learning any routes from ISP1 and ISP2. There are two choices. So you might be receiving a tons of routes from your the destination, your BGP peer, and sometimes you are installing all those routes you're learning into your routing table, and sometimes what you'd be doing is you would be discarding most of the routes and picking up only few routes which you are interested in by creating a route maps. So this command is used to filter out to see what routes we are learning and what we are installing. So let me do the same thing on the other neighbor. I will just copy paste this. Alright, show IP BGP summary. Alright, our configuration is ready. Now let's go and configure the BGP on the other side on router 2. Like I said, first thing first, ping our peer, ping 172.168.1.1. Alright, empty router BGP 200 neighbor 172.168.1.1 remote IS 100 description. I will say campus router 1, right? Okay, so let's see what happens here. Show IP BGP summary. Alright, our BGP is up. As you see, it came up just 2 seconds ago. And we are not learning any prefixes, zero routes. We are not learning anything from the router 1 as of now. Let's go to router 1 and see what is the situation here on the BGP. Alright, okay, the BGP is up for last 23 seconds ago, and we're not learning anything from router 1. Okay, if I do show IP route, on router 1, as you see, even though our BGP is up, but we are not learning any route sitting behind this router 2. If I go to router 2, show IP route, router 2 is not learning anything. Let me see here, 168. These are the loopback interface IP is 168 and 20.1 is the OSPF, 172.168.1 is the link going towards the router 1, 180 loopback, 170 loopback, 40 is the VLAN number. Okay, so router 2 is not learning anything 100 and 200 on network, even though our BGP is up. Alright, so let's bring the BGP on the router 3 and we will configure, we will resolve that issue too. So here router 3, as you see, I don't have any BGP configuration, so set BGP. There is nothing configured, so let's go ahead and configure the BGP here. Connect router BGP 300. This guy, let me move this on. This guy, we're going to bring configuring the BGP for this router. Right, let's move this here a little bit. Neighbor 10.1.1.1 remote AS 100 description campus router 1. Oops, sorry. Inbound. And let's see what configuration we have on the BGP. Alright, show BGP summary. Okay, so the BGP is up and zero prefix. We're not learning anything from the router 1. Show IP route. You won't see anything learning behind the router 1 on this one. Everything is locally connected. 153, 143, 133 are my loopback interfaces, or I may call it these networks here in my data center, right? And 60 dot and 30, 60 is the link connecting and the VLAN 60, and 30 is the network which we have OSPF configured between router 3 and external switch 3. So let me go on to the router 1. Router 1, nothing has changed here. If router 1 is not learning any route from router 2 or router 3, anything behind them, right? So let's resolve the problem step by step. So we'll go to config T. Let me run this command. Before I do that, let's see what routes. These are the routes from the router 1, right? They're not learning anything. So let me go connect T. I would give a command here that will help router 1 to advertise its directly connected routes to router 1 and router 3, right? redistribute connect. Okay, now let's see what difference it makes. Okay, so now router 2 is saying that they want one additional route 172.168.1.1 the directly connected network. Still, we are not learning 100.200 networks here, right? Through IP BGP summary, see, we have three additional new prefixes installed in our routing table from router 1. So we have 153, 172, 168, 143 my local networks, 10.1.1. This so now this router 2 has this route which we did not have earlier, 10.1.1. This network which is pointing to the ISP2 or the data center 2, and we have 192 and 60 dot network and 30 dot networks. Everything I see in this routing table. If I move this all, so basically all these routes from ISP2 we're learning through from the data center router 3. We have this here in our routing table. Alright, so let's go to the router number 2, traffic BGP summary. So we also have three prefixes in my routing table. Earlier it was only 0. There was nothing. But so something very important, if you notice here, even though we have three more prefixes in our routing table, we still don't have the 100 dot and 200 dot network in my routing table, right? So the reason is because the router 1 is learning 100 dot 200 dot routes in its routing table. If I may go here, show IP route. This 100 to 200 through OSPF, right? This 192.168.1.2 interface. So and this router 1 and router 2 and 3, they're connected on BGP. So we need to find a mechanism where we can put this OSPF routes on router 1 into the BGP, and the same thing we can do the BGP routes into OSPF so that the campus 1 and campus 2 would learn these newly formed networks. If I go on the external switch 1, see here, if I go show IP route, I'm still not learning anything new, even though my router 1 has learned so many new routes from its peers, but I'm not learning anything you see there. I'm not learning 10 dot network, which is pointing to my data center 2 in Dallas, and 172 network, which is pointing to New York. My external switch still doesn't have that. So now that we configured the BGP, we added a few routes here in our routing table. We still don't have full um, complete routes in our routing table. So I will stop this video here, and in the next video we'll configure. We will redistribute BGP into OSPF, OSPF into BGP. In that, then you will see how those routes will be populated in external switch 1 and external switch 2 and external switch 3. So our goal is to bring all those routes here from external switch 2 into external switch 1, and external switch 1 routes into external switch 2 and switch 3, which is in the Dallas data center here. Alright, that's all I have for this network. So let's please join the next video. Please look out for the next video series, part number 3, where we will be doing the route redistribution. Thank you so much.